Hey guys, so this week I had to do it a little different because I'm having some issues with my laptop, but you will still get the gist of it. So, here is our notes for this week. We are going to be talking about transformations in geometry. So, Jordan needs to choose an intersection for a new subdivision. He is responsible for the traffic flow of the community. The same intersection will be used throughout the community by translating, reflecting, rotating it. If the intersection is changed when it is reflected, rotated, or translated, Jordan needs to account for more of the cost for each variation he has. So basically, what a transformation is a change in size, shape, or way it is facing. We're going to go over each of the different kinds of transformations. There are 4 of them. I know some of you, we did this recently, well, I guess not recently anymore, but we did this towards the end of, before we went home for spring break. So if you remember, just go ahead and do those notes, no big deal. Or you can continue to work hard. Okay, so a transformation is a general term for 4 specific ways to manipulate a shape, point, or line. Okay. So, for example, I'll scroll into my little example box. If I have a oval, if I can just move it over, so my oval is the same, I can flip-flop it, which would be a reflection, right? Because you could see it is reflected over that line. I can make it larger or smaller, or I can rotate it. So here's oval 1. This is my line. Maybe oval 2 will be down here. So you see that it is a change. Next, you have a pre-image. That is your original image. Your image is your new image that's created by a transformation of your pre-image. Translation is a slide. So when you are moving or sliding your shape, the direction which your points on your shape are facing stay the same. It is literally just moving on the coordinate graph. A rotation is a spin of the shape. A reflection is when we flip the shape. Okay. You do not have to do any pictures for those if you do not want to. Isometry is a rigid motion transformation that doesn't change the size of a shape, also known as congruent transformations. So whenever you are moving a shape, dilation is the change in size. And your scaling factor is the value by which the sides of the shape are enlarged or shrunk. So basically it's the value of change in the size of shape. So, rigid motion transformations are which three? That would be a translation, a rotation, and a reflection. Similarity transformations means the size is changing, so you're going to only have dilation here. With rigid motion transformations, your shapes and lines are congruent to the original. With a dilation, they are no longer congruent, they are just similar. Okay? So, let me see. Turn my ink to shape on. Oops. Let's see if this works. Guess not. So there's my first shape, right? If we're talking about a translation, my shape may just slide. Put this into 4 boxes. My shape is just sliding. With a rotation, my shape is facing a different direction. With a reflection, you can see that my line or my shape was flipped over my line, and a dilation would be something like that. So we're going from small to big or big to small. So, a transformation. The shape or figure prior to the transformation or series of transformations is the pre-image. The result after the transformation is the image. We say that the pre-image maps the image. Under the transformation, if the vertices of the pre-image are ABC, then the image has a corresponding vertices A prime, B prime, C prime. Transformations are done on shapes, but more usefully on the shape of the vertice. So, if A, or point A, I should say, A is six 1 6. B is 4 8. And C is 6 4. if I were to draw out my graph, it would look something like A, B is 4, 8, B, C is 6, 4. Oh, damn. I'm going to redraw that line. Okay, so there's my triangle, right? These are all ABC. If I were to translate this, so I'm going to move my entire shape down 2. So my y is going to change by 2. My A would go to 1, 2, or 1, 4 would be my A prime. My B would go to 4, 6, which would be my B prime. My C would go to 6, 2, which would be my C prime. You can see, although it's not drawn perfectly, the size and shape didn't change, just where the shape was changed, okay? So, when you are doing these concept questions, it says the conceptualizer is there. That is all on the notes. So basically, it's saying, in this example, the figure is moved right 4 units down and to the left. So in our example, we moved the unit was moved 2 units down. Okay, so 2 units down, we translated, we slid our unit down. Units can be, or shapes, can be moved more than one direction at a time. Okay, so you can move down and to the left, you can move down and to the right, whatever floats your boat. So, if you were given the coordinates of M, 4, 7, under the translation T, -3, 2, what are you doing? So basically this is telling you, so you are doing, well, I'm sorry guys. This is where the real work comes in. M is x minus 3, y plus 2. I know it is plus because our numbers are -3, positive 2. Okay? So, for M, we now have 4 minus 3, 7 plus 2. M prime, which is our final answer, would be 1, 9. That is how you get it. So you need to make sure that you are aware of whatever numbers are right here. That is your translation. That is what you are going to be doing. Okay? So, remember, with the translation, you are just moving your x and y's every point by the same. So if they gave you 3 points, but your translation was t negative 3, 2, you're moving all those points by negative 3 and by 2. So, a flip is a little bit different, right? So, here's my, whoops, not what I wanted. Here's my graph. We're going to start over here. So we're going to do 5, 9, or 5. We'll do 5, 5. 5, 1. And then make this 3, make this 1. And then we'll do 1, 1. Here's my triangle, right? When I flip or make a reflection, it will be the exact opposite. So if I folded it in half like a piece of paper, it would lay on top of each other, is what I had on the other side. So here's my 1, here's my 3, here's my 5. So if I have a point at 1, 1, I'm going to still have a point. Oops, these are all negatives. I'm still going to have a point at 1, 1. Negative 5, 1 would be positive 5, 1. 5, 5 would be 5, 5. That is a reflection. So basically what changes, you're going from xy to negative x, y. The rule can be written in shorthand as r, x equals 0, or r equals y axis. Or a reflection of y equals x. So the line of reflection is perpendicular bisector of the segments joining the vertices or the vertex of the preimage to the corresponding reflected image. So basically all it's telling you is that your numbers will always be the same distance from whatever line you're reflecting over. So, some practice. If the reflection of n is 5, 7, under the transformation y equals 0, our prime n will be what? Well, we know that if y equals 0, you're reflecting across the x-axis. So that means that what's becoming next negative? The 7 in the y spot will become negative because that is the way we are translating. So reflecting over negative. So when you're reflecting over the y-axis, your y will become negative. Is my n going to change? No, it is not. Or my x going to change? No, it is not. So we will have n prime is 5, negative 7. So now, here's another part to this, right? We have, if D4 is reflected to D prime 10, 3, what is the reflection? In order to do this, you are going to take your 10 plus your 4 and divide it by 2. So I'm adding my two x values and divide by 2 equals 14 divided by 2, which equals 7. Once I have my number, I know that is what I'm reflected over. So my reflection is R equals, or R, X equals 7. Okay? The reason it is X equals 7 is because that is what we used. We used our X. So the line that it is reflected over would be where X is 7. So, because we have our meeting today, I am going to skip rotation for now, and I will come back to it afterwards, after our meeting is over. And I will post a secondary video with that half, but at least this can get you started if you need to get started, okay? Have a wonderful day, and I will talk to you guys in about an hour.